Uh, so good morning. In this section, we are going to discuss something regarding the geometrical properties of section. So this is a new chapter that we are starting. So this is a third chapter in our strength of materials of third semester of Diploma in Mechanical Engineering, uh, State Board of Technical Education, Telangana. So we have already discussed that in Telangana, as per now running curriculum, that is C18, uh, the engineering mechanics and strength of materials have been clubbed together and formed as this. So let us discuss. Right. So in this chapter, we are going to discuss the centroid and center of gravity and how to locate the centroid of basic figures and the expression of centroid of standard section. So for various standard section we are going to explain. Okay. So what are the geometric properties of the sections? So the center of gravity and the centroid and the moment of inertia are the geometric properties of the section. So let us define each of them. So the knowledge of center of gravity is important to maintain the bodies of equilibrium, as well as the moment of inertia plays a major role in bending moment, in finding the bending moment, and the strength and stiffness of the bending moment members such as beam depends on the moment of inertia of its cross section. Further, this cross sectional area of bending member is it has no effect with the strength. So let us discuss the geometrical properties of the sections. So the sections are centroid, center of gravity, moment of inertia, and radius of gyration. So centroid. So centroid is nothing but the point. It is a point at which the entire area of the given plane surface is located. So if you take a circle, the entire area of that circle is rotated at its center. So if always we take that centroid from the left bottom corner, that is nothing but the origin. So from the origin, if you see, the centroid is simply uh, at its center. So it can be measured as uh, from x-axis it is at a height of d by 2, and from y-axis also it is at a height of d by 2. Okay. So centroid is a point at which the entire area of a given specimen works. So, or you can also write as centroid is defined as the point on the plane figure where the uh, total area is assumed to be concentrated. Right? It is a point on a plane figure where the total area is said to be, it is assumed to be present. Okay. So centroid of a circle is d by 2 and d by 2. Next, center of gravity. So center of gravity is nothing but the point at which the entire weight of the body is said to be concentrated. Okay. So now let us discuss something. So if any body which is made up of large number of particles, and then its weight of the body is due to the gravitational force acting on them. So the gravitational force of these constituent particles are simply uh, they are acting upon within the body, and this point is nothing but center of gravity, right? So the center of gravity of a body is that point where the entire weight of the body is said to be located. Okay. So you can see. So you are considering a cylinder. So considering a cylinder, now where does the weight of this cylinder act? So weight of the cylinder will act at the center of axis of that, right? So now to take the center of the axis of that, you can take simply x by 2 and y by 2 and then length L by 2. Okay, so in this manner you are going to calculate the center of gravity. So centroid is the plane at which the total area is said to be concentrated. Center of gravity is the point at which total weight of the body is said to be concentrated. Okay, next, moment of inertia. So moment of inertia is nothing but it is the axis about which it is simply the moment of inertia is product of the area multiplied by square of the vertical distance, right? So now if I'm taking a particle, say uh, a rectangle. Now if I want to find a rectangle's moment of inertia, then I'll simply take uh, the distance from the axis, given centroid axis, and into that area. Mi equal to iy square plus ah square, I plus ah square or ay square. Okay, so this is how you calculate the moment of inertia. Okay, now uh, so once again let us discuss what is moment of inertia. Moment of inertia about any given section, it is simply that moment of inertia is equal to product of area multiplied with square of the vertical distance a into y square. So y square is nothing but the distance between the axis. Now let us discuss the example of this. So here you can see that moment of inertia about an axis, that is my xx, about this axis is simply, so ixx equal to integration of a into y square, where a is area of that particle and y is the distance from that center of axis, and y is the distance from the centroid to the axis. Okay, so this is how we'll be calculating the moment of inertia. Next, radius of gyration. Now, radius of gyration about any point is defined as the distance which, when squared and multiplied by an area, and gives the moment of inertia about that axis, right? So if you see here, radius of gyration k, it is denoted by I, k is equal to under root of I by a. We know that I is equal to a h square. Now if I want h, then it is simply under root of I by a. So k is equal to root of I by a. So where k is the radius of gyration, right? So moment of inertia can be simply taken as radius of gyration is equal to simply k equal to under root of I by a, where I is the moment of inertia and a is the area of that section, right? So next let us discuss standard sections. So this is a circle. So standard sections of the circle let us take. So for the circle is a standard section, and a square is a standard section, rectangle is a standard section, and triangle is a standard section. So these are all various standard sections, and whatever might be the geometric section that is given to us, we are going to find the we are going to divide that into the standard sections and do the job. So for the circle, let us discuss. So for a circle, the centroid is simply its center. So this center can be taken as d by 2 comma d by 2. Okay. Next, centroid. Next for square if you take. So for square, the center can be located at where the diagonals meet. So that is simply if A is the side of the square, then it is simply A by 2. So this is how we calculate A by 2 comma A by 2. So from x also, so this distance is from y axis is nothing but x coordinate, it is A by 2, and from x axis it is y coordinate, that is A by 2. Simply A by 2 and A by 2. Okay. So this is how you calculate the values. Next, so for rectangular. So for rectangle or a parallelogram, it is at the point where the diagonals meet each other. Where does the diagonals meet? So the diagonals meet at at the distance of half of its length and half of its breadth. Okay. You can see. So for a rectangle or a parallelogram, it is at the point where the diagonals meet each other. It is also a middle point of the length as well as the breadth of the rectangle. So for rectangle, it is the x coordinate is simply L by 2 and y coordinate is simply b by 2. So this is how we calculate the centroid for the rectangle. Next, so centroid of a triangle. Now for triangle, it is at the point where the three medians of uh, coincide, meet. Okay. So the three median points are, you can see, so for a triangle, it is at the point where the three medians, that is of the triangle meet. So median is nothing but the line passing through the connecting the vertex and the middlemost point of a opposite side. Okay. So you can see that will be at a distance of b by 3 and h by 3. Okay. So b by 3 and h by 3 is the centroid of the triangle. Next. So, so now let us go for the centroid of the semicircle. So for a semicircle, uh, it is at a distance of 4r by 3 pi. The centroid of a semicircle is at a distance of 4r by 3 pi from its base. It means simply its y term is 4r by 3 pi and its x term is simply r. Okay. So this is how we measure the centroid of a semicircle. Next. So centroid of a trapezium with the parallel. As you know, h is the height of this trapezium, and A and B are the parallel sides of the trapezium. Now, to find the centroid, it is simply at a distance of h by 3 into b plus 2a by b plus a. So the centroid from the left hand side, if you measure from the base, if you measure, the y value is simply h by 3 into b plus 2a by b plus a. Okay? This is how we measure the centroid. And from the x-axis, it is simply b by 2. We measure the centroid. Okay, next, center of gravity. Now, see for the hemisphere. Now, for the hemisphere, if you take horizontally, that is x term, it is simply d by 2. Okay. Next, if you take the vertical term, it is 3r by 8. Okay. So 3r by 8 is the value of the center of centroid for this. Okay, this is how we calculate the centroid. So x term is r and y term is 3r by 8. Next, so right circular solid cone. If you take a right circular solid cone, here the centroid will be horizontally. It is simply the x by 3, but vertically it is h by 4 from the base. So x term is x by 3 and y term is h by 4 from the base. Okay. If you take from the top, it is simply 3h by 4. Next, so let us take a cube. Okay, So center of gravity of a cube is simply this L by 2 from every face. So if you take from the horizontal it is L by 2 and from vertically also it is L by 2. Okay. Now center of gravity of a sphere is simply D by 2. Next, centroid for composite figures. Now, so we will divide the centroid for composite figures into two or more shapes, simple shapes, that is standard shapes, that is triangle, rectangle, semicircle, etc. Now centroid for this can be used by means of the method of composite areas. Okay, so for composite areas determined by method of, so for this what we do is initially, so first we'll divide the area into the definite shapes, definite standard sections. Then we'll find moment of inertia for everything, for centroid for everything. So for every part we are going to find this centroid. Thereafter what we do is we'll just make use of area formula and we'll find area also for everything. And then from the principle of moments, that is ax bar is equal to a1 x1 plus a2 x2 plus a3 x3 and so on. We are going to find the areas and summation of the areas, and the x term is nothing but the horizontal distance from the axis. Okay. So we are going to find all this. Next, similarly, we'll also find the y term, that is simply summation of x1 y plus a2 x2 plus a3 x3 plus a3 y3 and so on. And we'll find y bar also. So x bar and y bar is nothing but the value of the, it is simply the value of the centroid of that particular composite figure. Next, so let us look at the centroid of the following problem, that is T section. So we know that T section, shape of that T section. T section. So if I divide this composite figure, so it will give you two rectangles. So one rectangle is of 100 by 20 and the other rectangle is of 80 by 20 shape. Okay, so first figure is 100 by 20 and the second rectangle is 80 by 20. So you have divided this T section into two two sections, further two sections. Okay, so let us find solution. So it involves following steps. First, split the entire section into elementary areas, so that we have split it into two rectangles. Locate the individual centroid. So for every centroid you need to, for every section you need to find the centroid. Okay. Next, calculate the areas. So the given section is symmetric about y axis. Hence, so x axis lies on the y axis. Next, let us see. So this is the first one. This is the second one. So this is first one and this is second one. Now I am drawing this on the centroidal part. So this is the centroids. So how did we find the centroid? We'll see first. So this was 80 by 20 and this was 100 by, so in the previous problem we have seen that. See here. Let us go back. It is 80 by 20 and that is 100 by 20. So this is 100 by 20. So from the x axis, from the axis line we take. So from axis line if I take, so this is completely 100. So 100 by 2 is 50. So this is its center. Next 20 we want, but it is 20. But we want the distance from this origin of 0, 0. So from here it is 80 plus 10. So it is nothing but 90. And coming to this one, we know that it is 20 by 80. So 20 means it is simply 10. So if you see from the center, this side it is 50 and this side it is 50. So we know that this is symmetric about y-axis. So the x coordinates are lying on the y-axis. So it is also 50 now. Now coming to the y term. So from here the distance is simply this 80 by 2. We know that for rectangle L by 2 and B by 2. Okay. L by 2 and B by 2. So like that we'll get the centroids 50, 90 and 50, 40. So now the central centroid, how we are going to get that one we'll find. So we know that 100 into 20, area of a rectangle is L into B, that is 2000. Next for the second section, the area of the rectangle is 80 into 20, it is 1600. Next, so the y term it was given 90 and y term for this 40. So A into y, nothing but 2000 into 90 is 1,80,000. Next 1600 into 40 is 64. Now summation of all this, A1 x1 plus A2 x2. So centroid y bar is equal to sigma A1 y1 by sigma A1. Sigma A sum of area is equal to 3600. So 3600. Next. So now how will you get this y bar? So previously we took summation of a1 y1 by summation of a. So we are substituting all this. So this is nothing but sum of the areas A1 plus A2. This is A1 by A1 plus A2 by 2. So when you are doing this, when you are calculating everything, you'll get 67.78. So this is how we are going to find the centroid. So therefore we are concluding this. So today we have discussed definition of the centroid. Centroid is nothing but the point at which the total area of the plane remains located, said to be acting. Center of gravity is nothing but the point at which the entire weight of the body is acting. Next, locating centroid and explanation of centroid and standard components we have discussed, and definition of the moment of inertia we have discussed, and also radius of gyration we have discussed. Okay, so this is all what we have discussed, and in tomorrow's class we are going to find the centroid of complex shapes, and we are going to solve few more problems about this centroid of the complex shapes, and we'll also find, we'll discuss moment of inertia, radius of gyration, theorem of parallel axis and theorem of perpendicular axis. So coming to today's, we'll discuss once again that moment of inertia is nothing but the moment of inertia of any area with respect to any axis lying in its plane is defined as sum of the product of elementary areas and the square of the distances to this axis. So mi equal to sum of sigma a dA x square or sigma dA y square. Now radius of gyration, nothing but the distance of the point from the given reference of line is nothing but radius of gyration. So it is simply I is equal to ak square. So k equal to under root of 5 by a. So this is your radius of gyration. So to find the center of complex shapes, what we do is we'll first consider the laminar area, and then we'll divide that lamina into small areas A1, A2 and so on, and whose centroids are simply denoted in the terms of x1, y1, x2, y2, x3, y3 and so on from the x and y axis. Next, from the principle of moments, we know that a x bar equal to a1 x1 plus a2 x2 plus and so on till a n xn. Now x bar is equal to sum of a1 a x by sum of a. So where sum of a is total area of the composite figure, sum of the individual areas, then x bar is distance of the centroid from the y-axis, and summation of ax is sum of the products of the areas of each component and its respective centroid uh, from your from y axis. So similarly, the distance of the centroid from y x axis is y bar is equal to sigma a y by sigma a. And some notes we have to remember that if area has an axis of symmetry, then the centroid will be on that axis only. So if it is symmetric about y-axis, then the centroid will also pass on that y-axis only. And for solid bodies, position of center of gravity is given by the equations x bar equal to sigma mx by sigma m, where sigma mx is nothing but the product of summation of product of the masses of the body, masses of the sections and the distance of the axis. And similarly, y bar is equal to sigma m y by sigma m. Okay. And one more thing is that the center of gravity of any object can be obtained by suspending it from different points. So if an object is suspended from certain point on its surface, then equilibrium will occur when the moments balance. So under these conditions, the center of gravity will lie somewhere on the vertical line through that point. Okay. So if an object is suspended from other point, then equilibrium occurs, the center of gravity will lie on somewhere on the vertical line. So the point of intersection of these two lines will give the location of the center of gravity. Okay, so to find the center of gravity of any body, then you should simply take the uh, point of intersection of the lines suspended from the x-axis and from the y-axis. So this is how we are going to find the moment of inertias and centroids and center of gravities of the geometrical figures. So which are required to find the moment of inertias. Okay. In the next class, so this is how we are doing all the problems. And in the next class, we'll discuss uh, the further topics, that is theorem of perpendicular axis and theorem of the parallel axis. Okay.